Let us look at proposition number 33 of book 11 of Euclid's Elements. The proposition says similar parallelepipedal solids are to one another in the triplicate ratio of their corresponding sides. So here we have two parallelepipedal solids AB and CD, and these two solids are similar to each other, which means their corresponding sides are in proportion and their angles are equal. What the proposition is saying is that solid AB is to solid CD is equal to AE is to CF in the triplicate ratio. So let's see how we can prove that. So what we'll do is we'll copy this solid to E. To do that, we extend AE to K such that EK is equal to CF. Then we will extend GE to L such that EL is equal to Fn, and we will extend HE to M such that EM is equal to FR. Then we will complete this parallelogram LK and we'll build the solid. So now this solid KP is equal to solid CD. We are going to build a solid on LK, the same height as EH. And then we are going to build a solid, or first we will build a parallelogram GK, and on top of that we'll build a solid. So let's do that. Now that we have constructed these two solids, let's see how we can prove the proposition. AE is to CF as GE is to FN as EH is to FR. Why? Because remember, these two solids are similar. That means their sides are also, corresponding sides are proportional. So that is what this statement is showing. But CF is equal to EK, EL is equal to FN, and EM is equal to FR. So we can do the necessary substitution and say that AE is to EK as GE is to EL as HE is to EM. GE is to EL is equal to the parallelograms on them. So parallelogram GK and parallelogram KL are on GE and EL. So they are also in the same ratio as GE and EL. And since GE is to EL is equal to HE is to EM also, that means the parallelograms on HE and EM will also be in the same ratio. So the parallelograms on HE and EM are QE and KM. Parallelogram AG and parallelogram GK, whatever ratio they are in, the same ratio the solids on them will also have. So that means parallelogram AG is to parallelogram GK is equal to solid AB is to solid EO. Now parallelogram GK is to parallelogram KL. They have a ratio. The same ratio will be that of the solids on them, which means parallelogram GK is to parallelogram KL is equal to solid EO is to solid QL. And then parallelogram QE, where is QE? QE is to parallelogram KM as a solids on them, which is solid QL is to solid KP. So just look at the sequence. We established a proportion between AB to EO, from EO to QL, from QL to KP. And this should give you some idea that solid AB, solid EO, solid QL, solid KP, they are in continued proportion, which means solid AB is to solid KP in the triplicate ratio of the first and the second. So solid AB cube is to solid EO cube. Okay. Now solid AB is to solid EO is equal to AB is to EO is equal to parallelogram AG is to parallelogram GK, because those solids are on these two parallelograms. And these parallelograms themselves are on these two lines, AE and EK. So that means solid AB is to solid KP, AB cube is to solid EO cube, we substitute it with AE cube is to EK cube, because AB is to EO is equal to AE is to EK. So we have shown that solid AB and solid KP are in the triplicate ratio of their corresponding sides. But remember, EK is equal to CF and the solid KP is equal to solid CD, which means solid AB is to solid CD as AE cube is to CF cube. So finally, we have shown that the similar parallelepipedal solids are to one another in the triplicate ratio of their corresponding sides. So that is proposition number 33 of book 11 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.